Imagine waking before sunrise. The air is cold. Smoke from last night's fire still hangs between the trees. Your stomach already aches with hunger. Then someone in your group uncovers the prize that was supposed to keep everyone alive through the week. A pile of meat, but something has changed overnight. The smell is different. Sweet, sour, heavy. Flies cover every surface. The color has turned dull. A thin, wet shine creeps across the skin. Today, you have only two choices: eat it or starve. For almost all of human history, there were no refrigerators, no freezers, no expiration dates, and no food safety inspectors. Yet our ancestors survived for more than 300,000 years. They hunted massive animals that weighed over 4,000 kilograms, carried meat across scorching landscapes, and sometimes stored it for days before eating it. So why didn't rotten meat wipe them out? The answer changes how you see not only ancient humans, but your own body. Because what looks like a deadly mistake today was once a battle that shaped human evolution itself. Around 1.8 million years ago, early members of the genus Homo began relying on meat more than ever before. Fossils from places like Kubifora in Kenya show stone tools lying beside butchered animal bones, complete with cut marks left by sharp flakes of rock. Meat was a miracle food. It packed enormous amounts of calories, protein, iron, and vitamin B12 into a small package. A single successful hunt, or even finding the carcass of a dead animal before other scavengers, could feed dozens of people. But meat had one terrifying weakness. The moment an animal dies, another living world wakes up. Inside every carcass are billions of bacteria. During life, the immune system keeps many of them under control. Death removes those defenses instantly. Cells begin breaking apart. Enzymes digest surrounding tissue. Bacteria multiply by the millions every hour. Within just one day in warm temperatures, entire colonies can spread through muscle. Today we know familiar names like Salmonella, E. coli, and Clostridium perfringens. Some strains release toxins powerful enough to cause severe dehydration or even death. Modern refrigeration slows this explosion dramatically. Ancient humans had no such protection, or so it seems. In 1999, researchers studying traditional hunter-gatherer societies noticed something unexpected. Groups living in harsh environments often treated freshness very differently from modern industrial cultures. Foods considered too old by supermarket standards were sometimes deliberately eaten after controlled aging, drying, smoking, or fermentation. These weren't random risks, they were strategies. But here's where it gets stranger. Not all rotten meat is equally dangerous. Rotting is not a single process. It is a competition. Different bacteria arrive at different times. Some simply break down tissue. Others release deadly toxins. Temperature, humidity, insects, sunlight, and even which animal died all change the outcome. A carcass left beneath the hot African sun could become dangerous within hours. The same animal resting in freezing northern climates might remain edible for days. This mattered enormously during the Ice Age, beginning around 2.6 million years ago and continuing through repeated glacial cycles. Huge parts of Eurasia experienced temperatures that naturally slowed bacterial growth. Mammoths, woolly rhinoceroses, giant bison, and wild horses sometimes froze where they died. For ancient hunters, winter itself became a refrigerator. Archaeological evidence from sites across Siberia suggests that cold environments allowed humans to use animal resources over extended periods instead of consuming everything immediately. Except there was a problem. Most ancient humans did not live inside permanent winters. Many groups survived in Africa, the Middle East, and Southern Asia, where heat accelerated decay. So how did they avoid poisoning themselves there? Part of the answer may have been written inside their stomachs long before they understood what bacteria even were. In 2015, researchers examining the human stomach found something remarkable. Your stomach acid is among the strongest produced by any mammal on Earth. Its average pH ranges from about 1.5 to 3.5, acidic enough to dissolve bone over time and kill many dangerous microorganisms before they ever reach the intestines. When scientists compared stomach acidity across dozens of species, they found an interesting pattern. Animals that regularly eat carrion, dead animals already beginning to decay, often possess extremely acidic stomachs. Vultures are a famous example. Their digestive systems destroy pathogens that would kill many other animals. Humans are not vultures, but compared with many primates, our stomach acid is surprisingly powerful. Some evolutionary biologists have proposed that this may reflect an ancient period when early humans frequently scavenged partially decayed carcasses alongside active hunting. It remains a debated idea, but the evidence is intriguing. Imagine finding a zebra already killed by lions. The predators have eaten their fill and disappeared. Hyenas are still hours away. If your group reaches the carcass first, walking away means losing thousands of calories your family desperately needs. Eating carries risk. Starving carries certainty. Natural selection doesn't reward perfect choices. It rewards the choices that leave descendants. Over thousands of generations, individuals better able to survive occasional exposure to contaminated food may have gained an advantage. But even the strongest stomach acid had limits, because one invisible threat could survive the journey, and when it did, an entire camp could fall sick at once. One of the greatest dangers wasn't always the bacteria themselves. Sometimes it was the poison they left behind. Certain microbes produce toxins that remain dangerous even after the bacteria die. One of the best-known examples is Clostridium botulinum, which creates one of the most powerful natural toxins ever discovered. Modern outbreaks are rare because food preservation is carefully controlled, but without that knowledge, ancient people faced risks they couldn't even see. Fortunately, those toxins don't appear in every spoiled animal. They require very specific conditions. Even so, eating the wrong piece of meat at the wrong time could cause severe illness. An illness in the prehistoric world wasn't just unpleasant, it was a survival crisis. A modern case of food poisoning might keep you in bed for 2 days. You drink water, take medicine if needed, and recover. An ancient hunter had none of those options. Severe diarrhea or vomiting could strip liters of water from the body in a single day. Without clean drinking water nearby, dehydration alone could become fatal. A weakened hunter couldn't keep pace with the group. A nursing mother might produce less milk. An injured elder might never recover. One sick person could affect everyone. Anthropologists studying modern hunter-gatherer societies, including the Hadza, have observed how closely food is shared within camps. While these communities are modern people living in today's world, their sharing patterns provide clues about challenges ancient groups may also have faced. Sharing increases everyone's chance of surviving a failed hunt, but it also increases everyone's exposure if the food is contaminated. A single carcass could feed 30 people, or make 30 people sick. That's why ancient humans likely depended on something even more important than strong stomachs: experience. Long before anyone understood bacteria, people could recognize patterns. They learned that meat with a certain smell often led to sickness. Meat covered with unusual colors or heavy insect activity was more dangerous than meat that had simply dried in cold air. Older hunters passed these observations to younger generations, not through science books, but through memory. Knowledge became a survival tool. Fire became another. Evidence from sites such as Wonderwork Cave suggests humans were using fire at least 1 million years ago, although archaeologists continue to debate exactly when regular fire use became widespread. Cooking transformed meat. Heat destroys many harmful bacteria and parasites that would otherwise survive inside raw flesh. It also breaks down connective tissue, making calories easier to digest. Harvard biologist Richard Wrangham has argued that cooking fundamentally changed human evolution by allowing our ancestors to extract more energy from food. Fire could not neutralize every toxin, but it dramatically reduced many everyday dangers. Then there was preservation. Long before written history, humans discovered methods that slowed decay instead of trying to stop it completely. Thin strips of meat dried under the sun lost moisture that bacteria needed to multiply. Smoke from slow burning wood coated meat with compounds that discouraged microbial growth. In colder climates, frozen ground preserved carcasses naturally for weeks or even months. These weren't inventions made overnight. They were discoveries accumulated across thousands of generations. Archaeological sites across Europe and Western Asia suggest that prehistoric hunters often processed large animals immediately after the kill, removing meat, fat, and marrow before spoilage could spread. Bones were cracked open for the nutrient-rich marrow inside, which remained protected longer than exposed muscle. Nothing was wasted, because wasting food was often more dangerous than taking calculated risks. So, could rotten meat wipe out an ancient human tribe? It probably could. If an entire group unknowingly consumed heavily contaminated meat, especially during a season with little clean water and no alternative food, widespread illness might have followed. For a small band of only 20 to 40 people, losing several skilled adults at once could threaten the group's survival. But archaeology tells a different long-term story. Humans spread from Africa to nearly every continent. By around 45,000 years ago, they had reached much of Eurasia. By at least 15,000 years ago, they had entered the Americas. Along the way they crossed deserts, forests, mountains, and frozen tundra. They carried one constant challenge everywhere: food that never stayed fresh for long. They survived not because rotten meat was harmless. They survived because evolution equipped them with powerful stomach acid, culture passed down practical knowledge, fire reduced invisible dangers, and cooperation allowed groups to recover from inevitable mistakes. In the end, the greatest defense against spoiled meat wasn't a stronger body. It was a smarter species. The next time you throw away a forgotten package of meat from your refrigerator because it's one day past its date, remember that for almost all of human history there was no label telling you when food became unsafe. There was only your senses, your community, and thousands of generations of hard-earned experience. Human civilization wasn't built in perfect conditions. It was built by people who survived imperfect ones.